So we're going to work through this example before us, which is asking us to solve sine of theta is equal to a half for theta is an element of 0 to 2 pi. What's really helpful here as we begin is to actually visualize what's going on here. So I've got sine of theta. Well, let's come down here and let's graph y is equal to sine of theta in blue. And as we know, it just looks like this. I then am also going to graph a half. So as you can see here, I've graphed y is equal to a half, which is just a horizontal line. Now, when I set these two things equal to each other, what I'm doing is I'm trying to find the values for which they intersect. So I'm trying to find these intersection values. So in other words, the theta values for which these two lines intersect. So that's what I'm trying to do. And we'll return to this little diagram at the end of this example here. Now, the first thing that we're going to have to do in finding where they intersect is find something we call the reference angle. Can you begin by drawing for yourself a special triangle? Sine of what angle is going to be equal to a half? Well, I know that sine is opposite over hypotenuse, so it's going to be this one up here, isn't it? Because I'm going to get opposite over hypotenuse, and I know that this angle up here is pi on 6. We call this angle the reference angle. So I'm going to write ref angle. You'll see what this means in a second, but that's what it's going to be. And because we know that sine of pi on 6 is equal to a half, we know that that's true. A special triangle proves it to us. And this is going to be very helpful for us. But this isn't our only solution. Look at our domain. Our domain is from 0 to 2 pi, meaning there are more solutions than simply pi on 6. Let's draw our unit circle to help us visualize what these other solutions are going to be. So we're going to draw our unit circle here. It doesn't have to be pretty, just has to get the job done for us. There we go. All right, now I'm dealing with sine, right? Sine is my y-axis, and it's equal to a half. So that, let's say right there is a half, meaning that this point here is some value and a half. So my y value is a half, and so too over here, I've got some value and my y value is a half. So I've got two angles that I'm dealing with here. The first one is my reference angle. The reference angle, pi on 6, is simply the angle in the first quadrant. And we know that this works. If I put pi on 6 in, I get a half out. But there is also another angle for which I'm going to get a half out for my y value. And that's going to be this one in my second quadrant. Now, what's pi on 6 in my second quadrant? It's 5 pi on 6. So that means my answer is going to be when theta is equal to pi on 6 and 5 pi on 6, I'm going to get a half out when I sub it into this right here. So my answer is pi on 6 and 5 pi on 6. Now, again, you might be asking to yourself, aren't there more solutions to this? Couldn't we just keep on plussing 2 pi? And we could, but they aren't going to be solutions because here we're told that we only consider theta between 0 and 2 pi. So we're only doing one rotation of the unit circle. We're not doing multiple rotations. So we're not going, if I was to grab another color here, we're not going around again because now we've gone past 2 pi. Before we finish this up, let's just come down and look at our diagram here and we can visualize this again. As you can see, I've drawn sine of theta only for 2 pi. So the domain is only for 2 pi. And as you can see, there are only two places for when it intersects when the domain is 2 pi. One is at pi on 6. Wait, let me keep the colors the same, shall I? Just to be fancy. One is pi on 6, which is what we saw here. This one right there, pi on 6. And the other one is in orange, is 5 pi on 6, this one here. 5 pi on 6. So these are the only two theta values for which we get intersection points. I'm not going any more. My domain stops at 2 pi. So you really have to keep your eye out on this domain to figure out how many solutions you're going to have. But hopefully this is a good first example that kind of gets your head around what it means to solve a trigonometric equation and just how to think it through. So hopefully you have found this useful.